Hello, my name is Shanthy Rahmawati. I'm from Physics Education, Jakarta State University. I will talk about the physics of the formation of auroras. Aurora is one of the natural phenomena in the form of a tinge of colored light that moves over the north or south polar sky. Basically, auroras are formed due to collisions between charge moving in a magnetic field. Do you remember the physical material magnetic field? One of the sections discussed is the charge that move in homogeneous or uniform magnetic field. What if it's not homogeneous? For example, the magnetic field is so strong at the end of one, weakens in the middle, and strengthens again at the other end. Well, let's start analyzing the physics of the formation of auroras. Earth receives charged particles from the sun, stars, or celestial bodies. The meaning of the charged particles is electrons and protons. We call them cosmic rays. Supposedly, cosmic rays cannot get close to the Earth's atmosphere because they bounce due to the Earth's magnetic field. However, cosmic rays remain trapped in the atmospheric layers that form the Van Allen radiation belt. These charged particles move against the Earth's magnetic field, where the Earth's magnetic field is very strong in the north and south polar regions and weak at the middle or equator. Charged particles moving at velocity in a not homogeneous magnetic field will still give rise to a magnetic force, but their motion becomes spiral. Uniquely, the motion goes back and forth according to the configuration of the magnetic puddle. Based on the feature, we can distinguish the motion of charged particles in homogeneous and less homogeneous fields. The stronger the magnetic field, the smaller the spiral motion. That's what happened in north and south polar regions. As we can see in the figure, is the difference in motion of particles in homogeneous magnetic field with speed that form an angle of 90 and less than 90. And next is we can see the motion of particles in a magnetic field is not homogeneous and velocity forms an angle of less than 90 and is the concept of aurora formation. The magnetic field in the region is so strong that the particle spiral motion shrinks its rotational radius. Chaos occurs and collisions between charged particles are inevitable. Collisions between these particles cause the appearance of a certain colored beam of light that we call auroras. The color of aurora depends on the particle that dominate the collisions. If the particle comes from the oxygen atom, then the color of the aurora becomes green reddish. If it's nitrogen, then it becomes orange reddish. Sometimes, auroras can also be blue purplish. Aurora is divided by two types. One is the aurora that have northern skies are called aurora borealis or northern lights, and the second is auroras that have southern skies are called aurora australis or southern lights. The term aurora is taken from the name of one of the goddesses of Roman belief, while the term borealis comes from boreas, meaning north wind in the Greek. The brightest aurora lights radiates depending on the activity of stars, the sun, and celestial bodies. Where the more particles are trapped, the more collisions. Shortly after more collision occurs, the configuration of the magnetic bottle strap will leak due to too many charged particles entering. This certainly causes the light to dim. Auroras can occur all the time, but the daylight is not the right time. Auroral light will be inferior to sunlight. Auroras will be very clearly visible when the sky is very dark. If referring to the north as where we see the aurora, then Europe has several seasons. Sure, the most appropriate moment is one with a season that has more intense solar activity, such as summer.